Hi everyone, Kruskals algorithm. In this video, we will see what is the meaning of Kruskals algorithm and their applications, and what is the MST, minimum spanning tree, and we will see the steps to find the minimum spanning tree by Kruskals method, and we will solve some questions of the previous year question paper. Okay, now we'll see what is the meaning of Kruskals algorithm. The Kruskal algorithm is a fundamental method used in a graph theory. It is one of the fundamental method used in a graph theory to find the MST. To find the MST means minimum spanning tree. To find the minimum spanning tree, it is a minimum spanning tree. It is a weighted and connected and undirected graph. It is a weighted and connected undirected graph. It's a greedy algorithm. Kruskal algorithm is a greedy algorithm that builds MST, that meaning minimum spanning tree, by selecting the shortest edges. We in every step, at each step, in every step, we are selecting the shortest edges only. That does not form a cycle, and it should not be form a cycle. Okay, while solving the questions, we will come to know. Okay, in every step we are selecting the shortest edge, and we need to check that one. It should not form a cycle. That's two is very important. Okay, now we'll see the applications. The Kruskals algorithm used in a various applications of network design, optimization, problem solving, and TV networks, and many others also. Okay, next is, what is the minimum spanning tree? The Kruskal algorithm we used to find the MST, to find the minimum spanning tree only. What is the meaning of minimum spanning tree? Okay, what is the meaning of this one? So this is the minimum spanning tree is a subgraph. It is a subgraph. It includes all the vertices of the graph. Okay, what is the given graph now? It includes all the vertices, and it should be a connected. It should be a connected, and it does not have any cycles or loops in that one. Okay. A minimum spanning tree is a subgraph such that all the vertices exist. That means all the vertices should be included. Suppose if the main graph having the 7 vertices, the subgraph should also have the compulsory. We should include all the 7 vertices. Edges, no. Okay. We'll see while solving the question. And it should be connected. It should be connected means it's not. It should be connect to all the edges together. Okay, the graph connects all the vertices together without forming any cycle. Without forming any cycle. Here it's not. There is no cycles in that subgraph. Okay, with the minimum possible total edge of the weight. We are selecting here minimum weights. Okay. Here, what is why we are calling this is the minimum spanning tree means that the reason is here the sum of the weights of the edges is here minimum. We are selecting in each step the minimum weight only. That's the reason we have it's given the name is a minimum spanning tree only. Okay, its name itself tells us it's a minimum spanning tree. The sum of the weights of the edges is a minimum, so we called as a minimum spanning tree. Now we'll see the steps for solving the minimum spanning tree. It's to find the minimum spanning tree with the n vertices. See here, it has the n vertices. Number of vertices is here n. Okay. Remember this one, it has the n vertices. Now first, what is the first step here? We have to sort all the edges in the graph by weight in a ascending order. We have to sort all the edges of the graph weight according to the weight in a ascending order. Okay, they will give the weights. You have to write the edges according to the weight ascending order. Okay, next step is here, select the shortest edge. That meaning is or with a minimum weight. First we need to select the shortest edge. After that, the third step is here, keep including the next minimum edge. First we have to select the shortest edge we need to select. After that, in the third step, we keep including the edges with the next minimum edges. We are including next minimum edges to the MST as long as no cycle is formed. We need to check this one. It should not form a cycle. Okay, it should not form a cycle. And see here, if suppose its cycle is forming, we need to skip that edge. Skip the edge if it is creates a cycle or loops. If it is creating that, if any edges is creating any cycle or loops, we need to skip that edge. Okay, it is the third step. And the fourth one is here, it's a valid MST, means it is a correct MST, has the exactly n minus 1 edges. What is n here? N is the number of vertices. If number of vertices, suppose assume that it is a 10 vertices, then edges should come. The valid MST exactly has how many edges? 9 edges will come. Okay, how many vertices is there? Minus 1 edges will come. So you can cross verify this using this one. It should have the n minus 1 edges. Remember, n is here. What is the n here? N is the number of vertices. Okay, the valid MST has exactly, not less than, not more than. They're telling here exactly n minus 1 edges. If it is, suppose if you are not getting n minus 1 edges, then you assume you consider that you did something mistake in that one and do first again. Okay. where n is the number of vertices. So valid MST has exactly how many edges here? N minus edges. Suppose it's exactly 10 vertices means it should be a 9 edges. If it is the 12 vertices means it should be a 11 edges. Okay, the valid MST has exactly 11 edges. Okay, after that we stop adding the edges once you reach this number. Once you reach this number, you stop adding the edges. Okay, after you add, then also it will not possible because it forms a cycle. Okay, it will stop automatically when it reaches the n minus 1 edges. Okay, while solving the question we will see this one. Okay, then sum of the weights. After that we need to add all the weights of the edges. That is the total cost of the minimum spanning tree. Okay, the sum of the weight there is the n minus 1 edges will the constitute required minimal cost of the spanning tree. You can call it as cost, value, weight. All the meaning is same only. In the questions they will use what is the cost, what is the value, what is the weight. All the meaning is same only. Okay, now we will see the question. So we will solve directly from the previous year question papers only. The questions. It is a 2024 BCA first semester Bangalore University. So they have given here for the 8 marks. Okay, it's a very important and it's very simple also. If you understand, it's a very simple also. Okay. The question is here: obtain the minimum cost of spanning tree for the following graph using the Kruskals algorithm. They asked for the 8 marks. Okay. This is the question here. How many vertices we will count here? 1, 2, 3, 4, 5, 6, 7. They have the 7 vertices. Though so our MST should contains how many edges here? 6 edges. Okay, remember that one. So I wrote the question here. Okay, I wrote the question. They told here obtain the minimum cost of spanning tree for following graph using the Kruskals algorithm. So before solving this question, I will summarize once again what we studied about this one, MST. What is the first we have to remember what is the meaning of MST. That is very important. According to that one only we will solve. Okay, first I will write briefly here what is the meaning of MST. MST, how to find out and what is the meaning of MST means this is the subgraph. MST is this is the what is this one? It is a subgraph of this given graph. It is a given graph. This is the given graph. The MST is the subgraph of this graph only. Subgraph of this graph. It contains all the n vertices. If it has how many vertices? 7 vertices. It includes all the vertices. It includes all the vertices. Suppose it has the n means it contains all the n vertices. And what are the edges will come here? N minus 1 edges. N minus 1 edges. Okay, you remember this one. This is the very important. And another next thing is it should be a connected. It's not it should be compulsory connected only. Connected means that meaning is it should connect to each other. It's not like one second. It's a connected means see it should be a connected like this. Okay, if it is a connected. Disconnected means if you this is one subgraph, this is the second subgraph. See, I will draw here. If it is I draw this edge, it's not connected. This is the vertices. If it's not connected, then it is called disconnected. So minimum spanning tree is not disconnected graph. It should be a connected graph only. It should connect like this. It should connect to all the vertices. Okay, it should be connected. And another one thing, it's no cycle should form. No cycle should form. No cycle should form means it should not be closed. See here, if it's like this, if it is closed, the figure is closed, then it is called as a cycle. It forms the cycle. Okay, it should not be cycle. It should be open like that. All the edges should open. It should not be closed. If it is see here, if it is closed like this, it will form a cycle. Okay, then it does not has no cycles. And another one thing, we need to select here shortest edge at each step. Selecting shortest edge at each step. At each step we are okay. If you remember these points, then it's very easy to solve this one. Okay, what is that one? It contains all the vertices from the main graph, and it should contains n minus 1 edges, and it should be connected and no cycle form, and we have to selecting in every step. We are selecting here shortest edge at each step. Okay, in the steps we studied already. First, what is the first step here? Sort all the edges in the graph by weight in an ascending order. We have to write all the edges by weight in a ascending order. Okay, I will write all the edges ascending order. So what is the weight? The weight, otherwise values, you can call it as values also. What are the values they have given here? 2, 5, 4, 3, 6. Minimum is 2, maximum is 6. So first we have to write in a ascending order. So minimum to maximum. So what is the smallest here? BE. So I will write here BE. What is the value? It is the edge. This is the edge and this is the value. Value, otherwise cost, you can call it as weight also. Okay, what is the value of this one? BE edge here? 2. After that only 1, 2 is there. Okay, just check that one. After that 3. Next minimum is here 3. That is AC and EF. AC is 3 and EF is here 3. Values I am writing. In only 2 is 3. Next is 4. How many 4s is there? 1 and 2. Again 2 only. BC and FG. BC is 4 and FG is here 4. Only 2 are 4. After that 5. How many are there? 1, 2, 3. AB, CD and AG. AB, CD and AG. What are the values of this one? 5. Okay. Next 6. How many are there? 6 are 3 here. BD, DE and DG. BD, DE and DF. DF this one, not DG. DF. It is a 6. 6, 6. After that, na, just cross verify. Count the edges here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has the 12 edges. Just check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One is missing. So another one is CF. CF is also 6 here. Okay. So you, after writing all, na, you just cross verify that one. Okay, first writing the all the sorting the all the edges according to the weights in ascending order. We have to select the shortest edge and we have to keep including the next minimum edges. Okay, first we have to select the minimum edge. So better option is first you have to write down all the vertices. It's easy. So no vertex will left. So because it's a MST contains all the vertices now. So how many vertices is there here? 5, 6, 7.